much for joining today's webinar. This is part 2 of a short webinar series that we're doing with Vlad. In today's webinar, we're going to be using the concepts learned in the last webinar and exploring how this essential medical software development standard is applied in SpiraPlan. And this will also include a live demo in SpiraPlan as well. Before we kind of get into the nitty-gritty, I want to introduce Vlad Plotkin, who is Director and Safety Critical Software Consultant at Inmarsys Limited and a longtime partner of Inflectra as well. He has extensive experience in the safety critical areas like medical, automotive, and aerospace. I'm also here with Dr. Shriram Rajagopalan, who's Inflectra's global lead on training and agile transformation, and is also very knowledgeable in this industry and knowledgeable about all things Spira as well. And without further ado, go ahead.
All right. Thank you, Audrey. In this presentation, we're going to be talking about 6304 applicability to Spira. Now, one of the things I want to mention is that when I'm referring to Spira, I'm referring to pretty much the entire product line. So it's for historical reasons, because when I started working with Inflectra, my first application was Spira Team, and then switched to SpiraPlan, and there was a Spira test used in one of the places. So I just collectively call it Spira. So everything we're going to be talking today is applicable to the entire product line. So, but here I'm going to be showing SpiraPlan, but generally it's all the same. So our agenda for today, we'll do a quick recap of 6304 standard, as for those of you who didn't take part of the presentation, the last presentation. And we'll take a look at the product structure, how we map in the product into Spira, talk about some artifacts and the relationship, how they will link them together, and we do a live demo, and then followed by the Q&A session. A couple of words about Inmarsys. We are based in Northampton in the United Kingdom, so got 10 plus years, more than 10 years experience in developing certification of medical devices that covers both IVDs and MDs. And primarily in the software area, so and documentation as well. So we're helping our clients to go through audits, to create the documentation stack, create SDLC, making safe and certifiable medical devices for UK, US, and the European markets. So that's basically the Inmarsys. You can contact me on this email, vladimir@inmarsys.com, or there's my phone number in there. So the presentation, I can share this presentation with you through Inflectra, and then you can get in touch if you get any questions or comments. A couple of facts about 6304. 6304 is a standard for SDLC, for software development lifecycle, for medical devices, not applicable to any other industry. It's specific for medical. And it basically tells you how you need to design your software, what's your process, how you're testing it, and how you're releasing it on the market, deployment, and so on. The main aspect of this is the defect tracking and risk management. So lots of stuff goes into the standard, and basically talk about how you configure in your software, how you develop in your software. And the standard is recognized by by a lot of notified bodies. I cannot say most, because I never worked with pretty much all notified bodies in every country. But FDA recognizes it, European Union recognizes it, and UK as well. So it's a very good standard to have. And normally when you have an audit, one of the questions they will ask, are you following this standard or not? And if you're not, you have to explain why. So medical industry, as you know, is regulated and audited. So at some point of your project, you will have an audit, and it's better if you just show that you're actually compliant with the standard, you're following the guidelines from this standard. For the purpose of this demo, I created a project which is called Advanced Blood Glucose Meter. So it's a totally imaginary device. It doesn't exist. So it's made by a totally fictional company called Acme Super Medical. So if this company actually exists, it's pure coincidence. So all the names I used in this project are pure, any mapping the real things is actually coincidental. So it's totally fictional device. The device itself, consists of several things, the blood glucose meter called DigiScan. there is a blood glucose measuring strips. So if you know how it works, basically you person your finger and then taking the droplet of blood, putting it on the strip and putting it inside of the device, and then give you some reading. So this is the advanced device. So it does have like Bluetooth connectivity for the printer made by Acme Super Printers. Got the quality control liquid, so you need to check that the device is operational. So once a month, instead of blood, you're using this quality control liquid to check that the strips are correct and the device actually operational. And then you have this finger piercing device to basically take blood off your finger. So that's a description of the project. How the requirement flow is done in the project. In any medical project, you have project level requirements. So called sometimes PRS, sometimes it's user needs, sometimes it's something else. So, but generally you have project level requirements. I'm not going to deep dive into those because that is done by the systems team. So it's generated outside of the software process. So someone else in the systems team and the company management decided that's what we're going to build. And these project level requirements including lots of stuff, which is not just software, but also the electronics, mechanics, packaging, regulatory, shipment, export requirements, and so on. So I'll show you how it's organized in Spira. Then from there, from this project level requirements, we're generating software requirements and electronics and mechanics and production. So production is something which is often forgotten, but it's actually required for design for manufacturing, and that's really a useful thing to have. And then what it allows you to do is to say, if you manufacture a device like blood glucose meter, you're probably not going to do it one per month. So you're going to do like 10,000 per month. So it's going to be a really big quantity, and you need to ensure that your devices are basically working correctly as they go off the factory. So you create the production requirements, so end of line testing, how they're going to be testing it, how they're going to be checking it actually works, how they're going to be programming the serial number, manufacturing data, the UDI, which is now required, and things like that. So, but lots of companies basically they don't know they need to do it, but it's good practice to have it here as well. As you know, Spira is very much a software people tool. It was designed for software people. However, during my time in medical industry, what I found that lots of other disciplines actually want to use it as well, because electronics people, they got the 661 standard and they need to follow certain process, like again, the test cases, the requirements, the EMI testing, YMC. And same as mechanical, so you do like drop tests, and they're doing the other tests applicable to the discipline. And they basically like the idea of having their requirements and the test cases all in the same place. In addition, it also makes very easy to trace all requirements from the project, because you can do very simple gap analysis. So whether you covered all the project requirements. So you have your software, electronics, mechanical, and production all in the same place. You can trace it back to the system level, so you can guarantee that all of your requirements at the system level are covered. So each requirement got linkage to the software tests. Sometimes it's one-to-one, requirement got one test case. Sometimes it's one-to-many, sometimes it's many-to-one. It depends really how the software test team creates the test cases. Because if your test cases are atomic, then they might create one test case which covers several requirements. Because as you go into the test case, you go into some other steps which will basically test other requirements within the same group, and so on. So that is the project flow. How are we going to map it onto the Spira? So remember, Spira team, the projects within Spira team program are linear. There is no tree. So what you can do, you create projects which cover in certain aspects. So for example, product requirements will map into project called system that will have all the system level requirements. So you can put there your product requirements, URS, user requirements, user interface requirements, and so on, whatever the system will generate. Then we have the software requirements, software projects. And here, instead of one project, one-to-one, like it is done in the product level, I'm creating 3 projects. Why 3? So one will cover the software requirements only. So what is normally known as SRS. And then we'll also have the SOUP level requirements, because as you know, for medical industry, for IEC62304, you need to do your SOUP testing. And SOUP is basically software which wasn't invented here. So software is of a known provenance, of a known pedigree. In FDA speak, it's called COTS, commercially off the shelf. Sometimes it's not really commercial, sometimes something you take off GitHub, and it's freeware, open source. But generally, it's not something you developed within 60304 standard. So even if you're using software from other parts of your company, say you work in a really big company, and some other department develops software within the same company, but it wasn't done to 60304 standard, you treat it as a SOUP. So for SOUP, you're creating your own set of requirements, what they need to do, how they need to operate. You get the functional, software, hardware, performance requirements. And then you need to validate it for use. You also need to do your known issue set analysis. So if you get the known issues, the bug list from the manufacturer is great. If not, it makes your life a bit more difficult, but such is life of third-party software. Tools is very much the same. So you define what tools you're going to be using in the projects, and you create in your requirements what these tools are supposed to do, and then you do tools validation. It's very helpful when the tool comes pre-validated. So for example, you can buy certain compilers, which will come with functional safety validation certificates to IEC62304 or to automotive 26262. So to the highest level, like several compilers do this, you pay like 2-3 times more for the certified version, which is understood. So they need to do some work, additional work for it. But that's what it is. So for electronics, mechanics, production, I'm not going to discuss this in details because we're going to be concentrating on 60304, and these things are outside of the standard. One of the things here I have is called Playground. So it's a special project which I tend to create for people on this specific project, on whatever project we're developing. What it is. Say startup normally have high workforce fluidity. So people come in and go in and they need to be trained. And you cannot rely that people will know how to operate within Spira team environment, from the day you hire them. So they need some time to accommodate something to play with. So for this purpose, I'm creating the project called Playground. It's basically a sandbox where they can explore any feature, any artifacts, anything they want without affecting anybody else on the project. Because you really don't want some newcomer comes to your software project and start playing, amending your test cases because they just don't know where to press. So you really don't want that. And that Playground is a useful thing to have. So also some test people, they tend to use Playground for the exploratory testing when they're just trying to figure out how to do something within the system, within the software, they use that. Now, this is a really scary chart. So lots of connections here and there, and it's actually simplified. So what it is, don't be scared by this, it's all very simple. So the project consists of, the main thing is requirements, and the requirements, the way I tend to create them are very simple, just atomic requirements, for the reason that if you start writing your requirements with lots of ifs and buts and conditions, it's very difficult to test. Because if you start putting conditions like this button, if you press this button and the blue light shall come on, but only if today is Thursday, but if it's Friday, it shall be yellow light, but on every third Thursday, it needs to be actually green. So something like that. It's very difficult to test. So that's why I'm putting my requirements really atomic. So pressing the button, this slide shall come on. That's it. Then requirements are linked to test cases. That's a primary thing for Spira. And I believe that the Spira has been created for test people in the first instance. Version 1 probably was created for test people. And then they bolted on requirements and bolted on some additional functionality. And then test cases, when they organize in groups and they test people create the test run and then they run it and generate a report. So test runs, once they finish, they're immutable. So as an admin, I can delete it, but there's going to be a record that such a bad guy, Vlad, just went and deleted the test run, which is a big no-no. So it's a non-compliance. So it's not really a good thing to have. But they're really immutable from the system perspective. So you cannot amend it. And it doesn't open people a possibility to massage the data, which is really, really good thing. So then we have documents. Now, the artifact is called documents, but it's not necessarily a document. It can be anything. It can be source code file. It can be video, it can be image. For example, when test people run in test case, they found the bug, they take a screenshot, and it's becoming a document. So when they're attaching it to the test case, or incident. Also, documents can be real documents, so you can import them from QMS. For example, when you're talking about coding standards, so if your requirement says the software shall be developed to this coding standard, it might be useful just simply attach the coding standard to the requirement and then it goes to the document so people know exactly what you're talking about. Incidents, I really like this name. It's very much similar to what in Jira they call ticket. So it doesn't imply that incident is not a bug, basically. It doesn't imply something bad. Incident is something happened. So incident can be a suggestion for improvement, can be defect, a bug, can be something they observed during the test, for example, or request to change the requirement, basically change request. It can be anything. So then there is a releases. So releases are collection of requirements and tasks which you allocating for implementation for a specific goal. So, for example, if you work in an agile environment, you can allocate, say, 10 requirements for this sprint to be implemented and tested. So, and then you, from releases, with releases together and requirements, you link them with tasks. So you can have requirement, task for requirement, and then you allocate this task for a specific release. And then at the end of the sprint, you get the status of what has been completed and what wasn't. Same thing with test tasks. Testers can operate also on a task level and attach it to release. Sometimes it works, sometimes it doesn't. Not because Spira is making some problem with the bug or something in Spira, but it's rather because of the velocities of different teams. So developers can go at one velocity, testers can go at different velocity. So they might have their own sprint time allocation. So they may have sprints for like 3 weeks or 2 weeks, whereas the developers can have like one week sprint or 1 month sprint. So it's really depend on how the project is managed. I'm not going to touch it here with more details. There's something to keep in mind. Then you can create reports, and report is really big thing in Spira, pretty much in the entire project, because you can generate your requirements, you can generate your release report, so your complete history of what was released and how. You can generate your traceability report, and this is something which is required by the standard, like a bug report, and something would definitely FDA want to see, and test report. So that goes into your formal test reports. Now we're going to go into the SpiraPlan demo. So before we go there, I'll just explain what we're going to be covering there. So we'll be talking about requirements, test cases, sprint planning, task creation, incidents, traceability, and reports. We don't have much time, unfortunately, due to the format of the webinar. So I'll only cover the basics. If you want to know something like in depth, something really deep question, please ask Inflectra. They have excellent documentation, and they're also very approachable, so you can raise a ticket or ask for support. They will respond. So this is, I'm not going to explain what it is. Basically, so I'm not going to go through every single item. So it's just the abbreviations used in this presentation. So if you want to familiarize yourself with it, you can ask for a copy of presentation and read it at your convenience. This is the demo project. So we have here electronics, mechanics, playground. Remember I mentioned that. Production, software, soup, system, and tools. So we'll start with system and go into requirements. As you can see, some people might be just, it might look strange to some people here. I only have numbers here in the names, so which is a bit unusual. Now, this is, the reason for this is we have to, software guys have to work within the company, which is basically governed by the quality management system. And lots of quality people, they create their own format for requirement numbering. So Spira itself got requirement number in here, so-called RQ numbers. The problem with those, they are not project specific, they are system specific, the entire SpiraPlan installation or Spira team installation. So it's quite possible that you start a new project and your requirements will start with number 10,000. So some quality managers don't like that. They want requirements to be written in a very specific manner. So for example, in here, this example, I got 001 is a project ID. The PRS is the describing what this requirement is for. So it's a PRS, product level product requirement specification, and 001 is a number within the project. So there are several ways of allocating custom numbers in Spira. I tend to go the simplest way, so I'm just using the name field. So if you click on the requirement, that's a name field. That's where the requirement number goes. And this is where the requirement description goes. So into description, detailed information. So if you don't like this idea, you can create the custom field and use the custom field for that. So the issue with custom field is that you will need to create your own SQL script to generate your traceability reports if you want to keep those numbers. But so also, one thing to remember, I think we discussed this, I like to write atomic requirements. It's very simple. So screen shall be able to display GUI as per the specification. So when powering on, device shall indicate powering on progress to the user. It's very atomic. So I'm not going to write an essay about it. And the typical way of creating requirements, which I've seen in quite a few places, so they put in name, put in the requirement summary, and here they put in the detailed description of the requirement. I tend not to do that. I just don't, because my requirements are so short, detailed the requirement is going to be very much the same as a summary. So I'm using this field for numbering instead. So this is the requirements, how I'm creating it. So what's also, you might have noticed that these requirements got structure as pretty much like in a Word document. So that is done so we can easily generate the document from the requirements in here. So I don't need to keep separate my Word document in one place and the Spira team requirements in different place. So because it might cause synchronization issues. So when you write in your document master is actually in Word, not in Spira, there will be time when we'll forget to synchronize those. So I go another way. I'm creating requirements here in Spira, and then I'm just generating a report, and that goes into Word. So it's the other way around. Another thing is the product linkages. So I mentioned that you can create the traceability matrix for all requirements, starting from system all the way to software and the electronics, mechanics, and so on. To do so, you need to go to product association tab and create linkages to your projects from this project. So this means you will be able to see the requirements and other artifacts in your other subsequent projects. It's one of those things people normally ask, I want to create this, why doesn't it work? So because you need to enable it. So then it works. So then we're very much done with the system level, and we go into software level. So software requirements are done in the exact same manner. So it's very much like as my SRS document. So I didn't cover the entire traceability for this project because more than 400 requirements. So it's going to be a huge job to do so. So I just concentrated on several requirements, and as you can see, these requirements got tests associated with them and got some tasks which are in progress, and they allocated to a release. So let's go into this requirement. And what we see here is a firma shall determine how the versioning by querying 3 GPIOs in wake operational mode as part of startup business operation. So there you go. This is my requirement. So I also have tests associated with it, like called dummy test case. I have task. So implement this requirement, and that is allocated to this release. And I also have association. And association is, remember, I talked about the traceability from the higher level to lower level. So this requirement depends on requirement 24 from PRS, and it depends on it. So we got the top-bottom relationship between these requirements. And you can create a requirement one-to-many or many-to-one. I'll show this to you when I present the traceability metrics, which are generated. So you will see that. Then I have releases. So for the purpose of this demo, I created 2 sprints. So take a look at the sprint 1. So create first variant of the software for demo release. So in this release, I allocated several requirements and tasks. So as you can see, this requirement, for example, requirement 12, got 2 tasks in there. And one task is for developers, another task is for testers, and they allocate different people. And this task doesn't have a requirement associated with it because it's just some create software framework, something generic. It doesn't really have a requirement for it because there is no requirement to create a generic framework. So then there's test cases associated with this release. So these test cases need to be authored and run. And this test, 2 of them were created but not run. And this test case 3 has been run and passed. And we have test run associated with the release. So it passed, everything great. And we have result here in the test case, in the test run. So we can take a look at it. So it says passed. There are two steps. Software shall be working. It works. And the test 1 shall pass. It passed. There you go. No issues. Passed. So this is our test run. So if you look at the tasks, so we can look at tasks independently of requirements. So they're all here. And we can see the progress of each task and who is it allocated to, whether it started or not. So it's very easy to observe those tasks, even if they're not associated with requirements. So sometimes you have a task which is not really associated with requirements or sprint. So for example, you need to create a document which is depicting some algorithm. So like take 2 months for scientists to create it. So you don't really want to link it to a software development sprint. It's just something which happens in the background, but you really want to trace the progress of this. So then next step, so we got the requirements, releases, tasks, and tests. The next big thing is source code. So this is our source code. It's connected, it's a Git repository in TeraVault. Now, not all people want to use TeraVault, even if it's free, I believe. It's free for any subscriber to Spira product. So please correct me if I'm wrong. the Inflectra, but some people prefer to use more familiar things like Bitbucket or GitHub because they started the project there, then decided to bring in ALM, and they just want to continue with the familiar environment. So you can connect it. It's very easy to do. There is a possibility of doing so via source code generation. So you can go here, do the third-party source code providers, and then you just you connect your source code from GitHub to this repository. Now, important bit is you only have one repository per project. So at least that was the case several months ago. So maybe it will change in the future, but generally you have one repository per project. So you can unify your software into, if you want to have different repositories, you can combine repositories and put it here, connected there, but generally that's the case. So you have your source code. So you have your commits, for example. This is a history of commits. You can view your source code. You can do pretty much whatever you want. You can do your commits, view your commits. You can do pull requests. I didn't do that, because I tend to work with the third-party GitHub or Bitbucket rather than TerraVault, but it is a possibility. But you can view all your commits here. You can see your history. An important bit about commits is this area. See, when you doing your commit, you can automatically allocate your source code, your changes, to a specific task, or to a specific requirement, or to an incident, to pretty much anything, which any artifact which allows to do so. So in this case, TK77 is a task. So if I go here, it says create software framework, and as you can see, there were several commits in here for this task. So basically explaining what I put in comments in Git when on my PC when I was committing things to repo. I put these comments, and these all comments are here, and they're all linked to the task. So it's a very easy way to trace where your code goes and what it is going to do and how it linked to your environment, your Spira team environment. So that is basically the code. Pull requests I don't really use. And then you have incidents, which are generally bugs. So for example, this incident is now resolved, and it's also linked to commits to incident 76. And this is where you get your number. So if you're unsure what incident or task you're gonna be linking your commit to, you just go to the task, check this IN number, and you know what you're gonna be putting here in brackets. So that's very, very useful thing to have. And this is my file. So basically my incidents, so if these files needs to be removed, they really don't belong to the project, so remove them. And then they get association with these commits has been removed. Perfect. So, and then I have history here, what happened with the incident itself. So now we talked about incidents. Let's talk about the software project. Let's talk about SOUP. So SOUP is very similar to other projects that have requirements. And for example, for this specific project, we're going to be using library for Nordic microcontroller, and we're going to be using HAL supplied by Nordic Semiconductors, printer driver supplied by Acme Super Printers, and so on. So we have our requirements for SOUP. So the printer driver shall be supplied the source code, shall be compatible, compiled by IAR compiler, and so on. So these are our requirements. They need to be tested. So the test team will create test cases, and it needs to be formally validated, and will go into the validation thing. So same thing goes with tools, exact same stuff. So we need to validate our tools. So we have, for example, JLink, our JTAG. Those who work in with embedded software, they know what it is. So JTAG SWD access for sync. And one thing to remember is the attachments. So remember I was mentioning documents. So we have here supporting material, this is our source code. So we can keep our source code within the requirement, and then, sorry, not the source code, the installation files for the tool within the requirement, and then we know exactly if some newcomer comes to the project, they need to install the tool, they know exactly where to take it from. So some tools, remember what I mentioned about the validation, exact same thing happening here. So some of the tools like Inflectra, SpiraTeam, comes with the validation certificates. So you don't really need to validate it. Your validation will be limited to, do we have certificate? Yes, tick, done. So, and this is how the certificate looks like in case of Inflectra, but you will probably have some other documents by your suppliers if you're buying pre-validated things. So that's the tools. So what is also important to see, so you go into documents. So here you are, all of your, so you got your supporting material here, which is your quality manager will probably ask for. So you have your, it's for IAR, that is validation certificates. You got your tools register. So you need to have your software configuration items register documents. So you have them all stored here. Now, sometimes it's storing it in some sort of IT repository and it's managed by IT. Sometimes people manage it here, but it's very easy to do. So sorry if I'm talking really fast and going really fast, but we have limited time. So we have a couple of topics to cover. So one of the things I didn't mention yet, but I will now, about tools, is that once you got tools in soup, it's quite important to freeze the versions. Because, for example, if you probably seen this when you come into your office and have Windows updated some drivers and your printer doesn't work anymore. So you curse on Microsoft, curse on Windows, whoever made your printer, your IT department, your boss, and pretty much the entire world. So it's okay when you have some sort of office task to do and your office task is delayed. So you cannot respond to this email today or something, not life and death situation. But if you creating a medical device and has some sort of update, and suddenly you cannot do a very important medical diagnostic task or say surgery, you cannot do anymore, you cannot do blood treatment or anything, that's becoming life and death situation. So you need to ensure that things like that, cybersecurity and the software is not updated by itself and it's controlled. Same thing when you're developing software, you need to know that your tools actually staying the same. Unless there is some really, really good reason to upgrade it. So, for example, compilers, you start with one compiler and you validate it for use and you use it for the entire project, unless you found really big bug, which is stopping you from progressing. And that's the reason why you're going to upgrade. So, again, when it comes to Inflectra, you can request them to not upgrade Spira. So for medical industry, they offer this service. So basically, if you started with version 7 or version 8, it will stay version 8 for the duration of your project until you tell them to upgrade it. Unless, again, there is some sort of really, really critical cybersecurity incident or something really problematic, then they will tell you why they need to upgrade it. Now, let's talk about documents and traceability. So SpiraTeam got a feature. So if you go, for example, to system level, it got a reporting center. So you can generate reports from here. So I created a couple of custom reports. So to do simple traceability and detailed traceability and generate my requirements documents. I'm not going to generate them live because it takes time and we're a bit limited. So I just generated them in offline and stored. So, but they are, trust me, they're generated by Spira. So this is our traceability for software. So I can see here the entire traceability for my software project. So requirements, probably this requirement 9 is tracing to these requirements at the PRS level. And this requirement 13 is tracing not just the PRS level, but also got tasks associated with it, got test cases associated with it, and it got a bug. That's probably why it's number 13. So it's not really working well. So you can create the entire traceability all across your project or product as well. So that is going to be the traceability matrix your auditors will ask for. In addition to that, you can generate your documents, like a product level document. For example, this is product level requirement. And you can see here, so you have here your PRS requirements, and you have the linkages to other elements of the system. So this is, for example, electronics requirement, and this is software requirement. As I said, you can have one-to-many, you can have one-to-one. So, for example, here you only have two, one from electronics, one from software. Sometimes you can have more than one. Here you have one requirement linked to mechanical requirement. So when you need to do your gap analysis, that's how you do it. So basically scroll, okay, do I have a gap here? Oh, it's okay, it's a header. But if I do have a gap here, then like that, then you need to do something about it. Basically, you missed the requirement. And it could be not implemented, it could be just an issue that you forgot to link it, but it's something for you to take a look at. And then same manner, you can generate the software requirement document. And as you can see, it's linking other way around. So the PRS, you are looking from the top level to the bottom. Here, you're looking from bottom up. And you have your software requirement specification, and you have your PRS level, so PRS linkage. So we were talking about this Nordic family of microcontrollers that's linking to this specific requirement in the PRS level. So that's a very easy way to generate your requirement documents, very easy way to manage them. So with that, I'm pretty much done with my live demo. So go back to the presentation, and basically, if you have questions, you can ask them now.
I do have one question that we can discuss now, which is, our data is sensitive and can't put things in cloud. Can we still use Spira?
Yes, we do support on-prem as well as cloud installations. So if you are having data sensitivity and stuff like that, definitely you can get the on-prem installations. The look and feel is going to be primarily the same. You will still access through a thin client architecture, like a browser. The only thing that will be required is you letting us know that this is on-prem, so that you maintain the updates in terms of, we are releasing constantly updates, like, every few weeks we are updating new information that will be available on the cloud, but it may not be available on the on-prem instance because you are the one who is responsible for updating them. So we do suggest that at some point in time, you have a game plan to update them on a constant basis so that you'll get the, the best features that we are constantly releasing. But to answer your question, yes, we support on cloud as well as cloud instances. Even on the cloud, if your data is very sensitive in some particular locations, like the regions and stuff like that, we use AWS. So we should be able to support you into the nearest, region, like Singapore, Australia, or US, Europe, those kinds of regions we will be able to support. So if you have any more specific questions, please reach out to us and we'll be able to answer case-specific questions.
I do have another question. We have different types of defects with different workflows. Does Spira support it?
The answer is yes. We do have different templates, not templates, workflows available within the same template. So let's say you have change request as a defect type and another one as an enhancement. Then you can basically have different types of workflows, but the workflows have to be associated with a specific type of defect. So if you basically say, everything is going to follow the same workflow, that's great. But if you have different workflows, like, new enhancement go through a specific process, whereas existing refinements go through a simplified process, then you can create those different workflows and associate them with different, types of defects that you currently have. So yes, we do have support for that.
We have another question from Brendan on tracing from a child to multiple parent requirements. How do you find the best way of doing it? Ideally, it wouldn't happen, but of course, in the real world, it does. User requirement examples, the first one being the software shall trace to current user. The second one, the software shall have secure access. Both of those would potentially trace to software requirements around login functionality.
Right, that's a great question. So this is one of the things that Vlad was mentioning in terms of requirements can be associated with multiple things. One requirement can be associated with multiple requirements and stuff like that. So there is a MTN relationship here. So when you are creating the requirements over here, you definitely would be able to come and say this. Well, first of all, the hierarchical structure gives you a little bit of a clue that, this is next, and stuff like that. But there is also a preference where people don't want to see this hierarchical structure. They would like to see a flat structure. So, if their business operations is that way, that's fine. In that particular case, you would be able to come to the association tab. Vlad is already going there. So right there in that particular thing, you would be able to come and say, I would like to associate this requirement with 2, 3, 4, 5 requirements as well. If you're having a hierarchical structure, probably a little bit more additional work here, because you are going and saying like, oh, this requirement is associated with the software requirement. This requirement is also associated with the software requirement. But in a hierarchical structure, you are able to see that, a little bit visibly. But if you do want to see that in a traceability report and stuff like that, then you may have to do that association. Vlad, you have other thoughts here?
Yeah, so it's in this report. So basically, that's the association here, one-to-many.
One-to-many, yep.
Yeah, so you might want to customize if you want to say have visual distinction here. So I only want to see like electronics. You can have like additional tab here to say electronics, mechanics, and software. You have expanded the expanded traceability matrix here, and you have the only those from electronics will go into here, or only those from mechanics will go there, and only those from software. I'm not sure if I'm answering the question really, but I hope I do. But yeah, generally you can have
Yep.
one-to-many relationship quite easily.
Correct.
All right, I think let's go with one more question maybe, and then we can wrap up the webinar today. So one question is, how do we model V-model to testing in Spira?
I think it's a good question. How do we model the model? So the V model in Spira, obviously you have the, if you remember the V model, so you have the product level requirements, and you have the architecture design and the actual implementation. So on the right-hand side of the testing, you have exact same thing. So you can test your system level requirements goes into the system project, and that's where you test them at the system level. The architecture and the design, there is a way to do so. So you can create your own, you can create additional things. I didn't demonstrate it during this presentation simply because of time limits. So, but you can create put your architecture within the, say, software requirements project. So you can have like 3 different sections in there. You can have the requirements, architecture, and design, and they're all going to be linked to the software level requirements, because you need to derive your software architecture from there. And then you can also have your test cases linked to those architecture and design documents. So, and you can generate your SAD and SDDs, detailed design document from those things. So that's how you map it basically. And then when it comes to the actual V model, you need to provide the reports. You can generate them test reports. So you can have your you can have your item test reports. You can have your integration test reports and the system level test reports. So you can basically, it's fairly easy to do so.
Vlad is completely right, in terms of test cases that are mapped to the requirements and, stuff like that. That is definitely the starting point for V-model for sure. And there is also another functionality within Spira, which is the test sets. Vlad, if you can just scroll down onto the requirements section or the artifact section and show the test sets, that will be good. So there is another thing called test sets, which is a collection of test cases. So once you have test cases that are basically doing verification at the the performance level, and you want to go into the next level like operational or installation qualification and stuff like that, you can come and say, I'm going to create, he's exactly doing that. So you can create a test set that includes a collection of test cases. And now you would be able to go and say, well, now that I have verified these things, I would like to have either new or existing test cases verifying this on a different environment, like QA to production or pre-production and staging and stuff like that, or some specific scenario that you would like to test for that particular environment alone, like penetration testing, security testing, and stuff like that. So it is very flexible in that you can either use the test cases model, or you can out that with test sets in addition. And so there is a lot of flexibility in terms of how you can support V model.
So there you go. This is your test set created with two requirements. So yes, you can at each level. So each level of the V, you can generate your test cases and generate your test runs for those levels. So
exactly. Thanks, Vlad, for running it right away. Thank you.
Yeah.
Well, thank you so much, both you and Shuram and Vlad. Thanks so much for, answering those questions. And I know that this is part 2 of our 2-part webinar. So I guess my last question to you, Vlad, would be, where can people find you? How can they contact you to learn more about this industry standard and kind of, continue the conversation with you?
Well, people can find me on my details listed on the presentation. So if someone interested, can please share the details with anyone who's interested, and I'll try to answer the questions if they have, or can give me a call. But please schedule it first, because we got different time zones. So don't call me in the middle of the night and asking some specifics about 60304. How does section 5.1 of the standard works? So yeah, I'm very approachable. So yeah, if you got a question or you want to know something, just give me a shout.
Fantastic. Well, thank you so much. And thanks again, everyone, for joining today's webinar. I hope that it was really useful for everyone. And thanks again for joining today.